In this video, we're just going to do a couple brief qualitative wave investigations using two PhET activities. First one, wave interference. So we've got a sink here that is dripping water into the bottom of the sink, well, a faucet that's dripping water into the sink. And we can look at this, and the blue is the peak of the wave, and the dark part is the trough of the wave. So I'm going to just pause that, and let's measure the wavelength. So wavelength is from peak to peak or trough to trough. So if we just go from the middle of one to the middle of the other, we've got a wavelength of about 2.6 centimeters. And let's see the period of the wave. And we will check out when the wave passes through the wall here. Oops. So 10 waves was 15 seconds. So about the period of about 1.5 seconds. So from that, you can figure out the frequency, and you can figure out the wave speed, and you can put those in the comments. So now we're going to add another drop and see what happens. So remember, we've got the blue representing the peaks and the darkest dark representing the troughs. So we can add one other thing here, and that is this little water level meter. So notice what happens as we play this. So right there, we've got a huge oscillation here. So you notice that it's so big difference, high, low, and so on. Here we've got kind of a grayish area. So let's see what happens if we measure this grayish area. The amplitude is very, very low. In this area, the waves are adding up destructively, so they're essentially canceling each other out. When we have a peak from the bottom drop, it's meeting a trough of the top drop, and when we have a peak from the top drop, it's meeting a trough from the bottom drop. So we've got the valley of one and the peak of the other adding up and almost canceling each other out. Here, we've got peaks adding up and valleys adding up, so we're getting something even bigger than what we had with a single wave, which we can actually test. So you can see for one wave, it's sort of in between what we had before. And no matter where I move it, we get that same effect, because there's only a single wave. There's no interference here. All right, I think that was all I wanted to do with that. So make sure with the other, you use the wavelength and the frequency to figure out the wave speed. So this one's going to be really qualitative, standing waves on a string. Didn't want to get it slow motion first. So you can see we've got a pulse that is moving in one direction and the other. So the pulse, when it's moving to the right and it hits the clamp, and then it bounces back on the bottom side. So that's a single wave. Now I'm going to make it go a little bit slower. And when we've got a wave when the wave was coming back, I sent another wave. So notice what happens when the waves meet each other. So the wave on the top basically just passes through the wave on the bottom, and right when the waves are one on top of the other, the line, the little string or whatever that is, simulated string, is flat. So this is similar to what you saw with the water, but basically just a wave at a time. So when the wave at the top meets the wave at the bottom, we get a cancellation, so destructive interference. And with the waves going this way with the single pulse, there's no way that I can add a wave on top that's going to add up to the wave on top, because it's not going to be able to catch up with it. So we need to do something a little bit different here. And for this one, we're going to do a manual. So notice if I move the wrench at just the right frequency, we get what's called a standing wave. Notice the green balls are pretty much always staying on that dashed orange line. So this time when I'm sending a wave down, it goes down towards the clamp, bounces back off the clamp, and they always meet in such a way that where the green balls are, there's canceling out. And notice where when the wave peaks, the peak in the valley is a lot higher than I'm moving the wrench up and down. That's because at those peaks and valleys, the waves are adding up constructively. So they're not canceling each other out, they're adding to each other. And at the green, the little green dots, they are canceling each other out. Pretty straightforward. Just to give you a visualization, the book describes things and it has static pictures. Heck, motion sickness. It has static pictures, but kind of helps to see the motion. So I encourage you to explore the waves on a string and the wave interference activity to get a good feel for what's going on. Thank you.